Yeah, good evening. This class we are going to discuss about the commodity polymers, and have already explained about engineering polymers in the previous videos. And this video we are going to discuss about the commodity polymers. Okay, what is the main difference between the commodity polymer and engineering polymers means? The engineering polymers, it has the property of mechanical and also thermal. Thermal property and mechanical property, it will be good in the engineering polymers, because that polymers it is used to for instead of the engineering materials like the high density materials. Okay, if you are using the high density material, it is quite difficult to reach the application. But in case of low density material, in terms of polymers, we can easily achieve the applications, right? And that is the main difference between the commodity polymer and engineering polymers. And here the commodity polymers, the first one is the polyethylene, and we call here we also called as PE, polyethylene. Here we are having previous engineering polymer, sorry, previous videos also I have explained CH2, CH2. The same formula here. If it is CH2, CH2, if it is a double bond, here it is happen, it is called monomer. It is not a polymer. But in case it is has the reaction link here, okay, that's why we call it as a polymer. That means it can react with another one CH2, and this side it can react with another one CH2. That's why we call this as uh, uh, polyethylene. That means polymer. And here you are having two different types of polyethylene. One is low density and another one is high density. Okay, high density, it is also called as HDPE. The symbol, it is recycling to HDPE. Okay, what is the meaning of this symbol is the numerical notation in the recycling for HDPE is 2. The numerical notation HDPE is 2. Okay, and what about LDP? That means low density polyethylene. That is numerical notation is 4. Okay, 4. And here is some of the applications are uh, juice jars and milk jug, food jars, and water cans, like and in terms of a house lavatory, chemical agents, and these things, it is comes under these are the application of low density polyethylene. And about high density polyethylene, and about the low density polyethylene, it is high density polyethylene. Why we are using high density polyethylene? For chemical agents, it is a highly non chemical reactive material. And for an example, in the house and the lavatory, we are using harpic. Okay, harpic, we are using ceramic cleaning harpic. Okay, that chemical agent, it is quite harmful to the human. If it is directly exposed to the human, it is the skin burning may happen, and some of the problem will arising, the human hazard will arising in terms of if it is leak into the environment. That's why we are going for the high density polyethylene. This high density polyethylene that has a high density of plastic material. Okay, that's why we call it as a high density polyethylene. And here it is a low density polyethylene. Here we are using a diluted version. Okay, it is a concentrated chemical that is carrying by high density polyethylene. But in case of low density polyethylene, we can carry diluted chemical agents. Okay, that's why we used these kind of polyethylene in the commodity polymers. Okay, this about the polyethylene CH2 and CH2. Here it is a one reaction link, and here it is a one reaction link. This is a structure actually. Okay, this about the polyethylene. And second one is polypropylene. Okay, polypropylene we also called as PP. Okay, polypropylene we also called as PP. And what is a property here? It is a high durability. High durability means here you are having a food container and home like tubs and buckets we are manufactured by polypropylene, and furnitures and the cosmetics box like we are using some cosmetic containers, like and the industrial application also we are using polypropylene and medicinal health. Okay, this is durability of the material is high, that means strength of the material is good, and also the lifetime is also it will be increased. Okay, that's why we are using the polypropylene. And here it is a chemical formula. Okay, chemical formula, here it is one reaction link, it need to react with another one carbon atom. Okay, another one carbon atom, here it is a one carbon, here it is a one link, it is to react with another one carbon atom. Okay, this is structure, one chemical one carbon atom and one CH3 molecule and one hydrogen molecule is react with one carbon, and another that carbon it's react with CH again CH2, and this CH2 it is react with carbon. Okay, this is the chain link, you can find the chain link. This is one group, sorry, this is one group. Okay, this is one group and this is one group. Okay, there you are having a n number of links, that's why we call this a polypropylene. It is a polymer, it is not a monomer, it is a polymer. Okay, here you are having a structure like this is the CH 3, this is the CH3 because one carbon atom, three hydrogen, and this is H, that means one carbon, one hydrogen atom, here it is located. Okay, here it is located, three hydrogen atom, here it is located, and two hydrogen atom, that means CH2 it is located here. Okay, this is a carbon atom, two hydrogen here. Okay, this is one carbon atom, one hydrogen here, this is a carbon atom and three hydrogen atoms here. Okay, this is the one structure. This structure is react with another one structure, that means relate with another one structure, same kind of structure. Okay, this is called the polymers. Okay, this is called the polymer structure here. This is called polypropylene. And third one is polystyrene. Polystyrene, it is very simple. Polystyrene, it is a low thermal conductivity, and the symbol is here, it is a numerical notation is 6. And polystyrene, the properties of the polystyrene, it is a low thermal conductivity. That means what? uh, uh, when we are going any kind of hotels or restaurants, they are giving the flexible bowl. Okay, flexible plastic bowl. Okay, that is made up of polystyrene. Okay, if you are holding the polystyrene cup over cup with you, okay, you cannot feel the heat, you cannot feel the heat of the food. Okay, because it is a thermal conductivity is very less. Why? Because of the molecules inside the molecules, you are having more air gap. Okay, it has more air gap. Okay, it is also low density also, it has low density and low thermal conductivity. It is one of the important application of the polyester. Okay, this is the chemical formula, and this is the application. Food, beverages, hot and cold refrigeration containers, and all is made up of the polyester. Okay, this is a PS, it is polyester, it is numerical notation. And another type of polymer is polyvinyl chloride. It is most familiar from for us because the PVC, the plastic fixtures, that means the piping fixtures which we are using in the house, that is called the polyvinyl chloride. Okay, polyvinyl chloride, and it is also, it has a good durability. And here why we call it as polyvinyl chloride, here on chloride element, element it is here. Okay, that's why we call polyvinyl chloride. Here it is a one reaction link, here it is a one here reaction link. Okay, totally it has three hydrogen, one monomer, this is a monomer. Here it is a three hydrogen, one chloride. Okay, that's why we call polyvinyl chloride, chloride for element, it is attached here. Okay, that's why we call this a polyvinyl chloride, and it is a high durability, and it is a good strength actually. Okay, And next one is polymethyl methacrylate. It's also called as PMMA. This is a formula actually. One carbon is react with one CH3 and another one carbon is react with H2 and another one carbon is react with another one carbon and oxygen, and this carbon is react with one oxygen and this oxygen is react with CH3. This is a formula for PMMA, and another one carbon is ready to react here and another one carbon is ready to react here. And here it is application, it is very simple. Home decors, have you seen any kind of photo and photograph, if you're taking any kind of like home decors, like this kind of home decoratives you can see in somewhere. Okay, that kind of application we can use by using of PMMA. And here it is a roofing, because it is a good density and good strength material and weatherability. It has the property of good weatherability and it can withstand any kind of weather situation. Okay, that's why we are using this kind of roofing in terms of the airport and malls. And you can see the transparent glass. Okay, it is actually not a glass, that is polymethyl methacrylate. Okay, this is about one kind of application of polymethyl methacrylate. And finally it is a recycling symbol. One is PET, polyethylene tetracrylate, and second one is polyethylene high density, HD. It is denote high density. And three is PVC, polyvinyl chloride, and polyethylene low density. It is notation is 4, and polypropylene it is PP, notation is 5, and polystyrene it is notation is 6. Okay, these all are the applications in the diagrams, you can easily understand. And seven one is which all are the plastic, it is not listed here. It is all comes on seventh notation, seventh notation. Okay, seven numerical notation, that is called, that is some of the applications. Okay, these all are some of the application. Polyethylene you can bottles, and high density you can carry high concentrated chemicals you can carry. Polyvinyl chloride, the piping fixtures, fittings we can use. And low density again water bottles we can use. Polypropylene, the refrigerate housing, TV housing, and all the things. And the polystyrene, the CD, that means compact disc material. And other plastic materials comes under the seventh one. Okay, this explanation about the commodity polymers. Thank you for watching, and we'll see the another one video. Thank you.